Senson from Madison College, James Madison Memorial High School, and in our astronomy classes we are going to do some drawing projects in order to visualize different cosmological systems. And in this case, this is an introduction to drawing challenge number 1 for the Ptolemaic model of the cosmos. There are going to be one of two different possibilities. You may have the assignment that is based on 36 months, so 3-year time period, or a 5-year period, 60 months. And so the one with 60 months is going to have a little bit more drafting, a little bit more work. The one with 36 will be done a little bit more quickly, but they're both very, very interesting. And if you have the time, I actually encourage you to download and try both. They lead to very, very beautiful pictures. So I'm going to get rid of my handouts and just place them off to the side here. And we're going to get started on this. The very first part of the directions to draw the Ptolemaic model, what we have to understand is this is going to be for a superior planet. So it says, get your piece of paper and place the Earth at the center of the page. Now, I've already gone and taken 2 sheets of paper. I've reinforced it with just a piece of tape going up the back. I gave it a fold in one direction and a fold in the other direction in order to create some centering marks. And now I'm going to take it and just put it down on my tablet here, my table. And what I'm going to do is just take a little dab of tape, and I'm going to come up here and make sure I stick this down to the counter so that it can't slide around too much. I just want to make sure it can't move around to me as I'm doing my demonstration. And the first part, now that I have my little crisscrosses here, it tells me to go ahead and draw a symbol for the Earth down in the center. Well, that just means a very, very tiny circle. And so what I'm going to do is just darken up my little crosshairs a little bit. And so I'm going to just go ahead and put on a little bit of a little crosshair right here. And remember, the Earth symbol is really just a circle with the plus sign in it anyways, and so that's really going to be my bullseye for the center of any of my circles. And so that is the symbol for the Earth. And once again, I'll just make it big enough that you can see it over here. It is just a circle with a plus sign inside of it going all the way to the outer edges. That's the symbol for the Earth. Okay, so that's step number 1. And next it says draw the orbit of the Sun 1 inch radius away from the center. So once again, if you do have something like a ruler and you have your drafting compass, we can go ahead and set our drafting compass to the 1 inch and draft a circle that way. Or I'm actually going to model doing it the way I recommend for those of you at home, which is if you have these little protractors that were a printout, make sure you print them out, cut them out as accurately as you can along the black line. And what we can do is just go ahead and bring these in. And because I have my double fold lines, I'm going to use the green lines here, but I can get the green lines lined up top and bottom and left and right, or you can use the red, really doesn't matter. But I like having a 0 up at the top if I can, so I'm going to go with the greens. And once I get it lined up as accurately as I can, this is a 2 inch diameter, 1 inch radius, which means I can just very lightly take my pencil and drag it around the outside edge. And what I'll wind up with is a nice little 1 inch radius circle on the piece of paper. So that is my orbit of the Sun. Remember, we're doing Ptolemy, so this is a geocentric, geostationary cosmos. The Earth is not moving, and the Sun is. The Sun is going to move around the Earth in this direction. Right? So it's going to go around in a counterclockwise direction from our perspective. It's going to move through the star field. We're basically freezing the star field. And on a star map, it's going to move eastward through the heavens, right? And then it says, all right, why don't we go in and place in 12 different months of the year. Now, we have to have a place that we start, and so what I'm going to do is just start up here at the top. It says the 12 o'clock position, and so this is away from me. It's going to be at the bottom of your diagram, so maybe I'll try to flip this and draw it for you. This is your 12 o'clock position, and so what I'm going to do is just draw a symbol for the Sun. I'm going to make it about the same size as that of the Earth, and remember the symbol for the Sun is a circle with a dot, and so just a circle with a dot is going to be the Sun symbol. And then it says, okay, so that's going to be my starting spot. From that starting spot, or time 0, what I want to do is mark the 12 months. And if I'm going to figure that out, 12 months, 360 degrees, 360 divided by 12, basically every 30 degrees is when I'm going to draw in another sun. So that's why we need my little protractors, is I know 1 month later the sun will be right here. And I could draw in my little circle, and I could put my little dot in the middle. And I could come back and say, okay, that's tick-tock, that's 1 month later. How about another month later? Well, it's going to be another 30 degrees. And so it's going to be, right about here. So this is 1 month in, this is 2 months in, and so on. And I could come in here and say, oh, well, then this is going to be, 3 months in, and so on, and mark it all the way around. In other words, what I want to have is all my little suns with all their little symbols in place, like that, with the little sun symbols. And I find it fairly helpful just to keep track of time, because it builds a little bit of memory, to actually number them. So I go 1, 2, and 3, and 4, and try to make a 5 upside down. That's all great, right? But number them, and what you should wind up is if this is your starting, spot 0, it should also wind up being month 12, right? 12 months to go all the way around once. So that's our basic reference. Now, the next thing it says is, let's go out, and it's a superior planet, so it's going to be much, much farther away than that. So what we're going to do is we want a 3-inch radius for the deferent of the planet. And same thing, I can take my giant protractor here, and I can line it up carefully, and I can trace the outside. Or I can take my compass, and I can say, this is a 6-inch, so I'll just go just barely outside the outside, get that adjusted. And what I can do with my tape reinforced is I can come and I can just swing that deferent arc out there into space. And that is the deferent. That is what the planet itself is going to move on. Great. Awesome. Next step. It says, now we got to take the epicycle. And for that, we're going to use the intermediate size protractor, the 1 3/4 inch radius, 3.5 inch diameter. And I punched out that little hole in the inside, and what it says is, what we're going to do is start up here at the 12 o'clock position. I'm going to put 0 up at the top of the diagram for you. And what we're going to do is we're going to locate that on my little circle there, and this is the epicycle. And so the middle of it is going to move, once again, in a counterclockwise direction. The planets tend to have their prograde motion in a counterclockwise direction. And it's going to move 1 month for every month of the sun. And it's going to go tick-tock around the outside. It's actually a continuous path, right? Constantly changing. But we're going to just punctuate and say, every month, let's take an observation and let's see where it is. Remember, though, the planet isn't on the center of the epicycle. It's not on this deferent. The planet itself is going to be on the outside edge of this little protractor. It's going to be on the outer edge of this protractor. Because it says start at the 12 o'clock position and put it up here at the outside. So whatever planet we're doing, we can make up our own symbol. Maybe we make a crisscross X inside of it instead. But this is going to be my starting position at month 0. I'm going to start at the 12 o'clock position on the epicycle, which is on the deferent. And remember, for a superior planet in the Ptolemaic model, the rule was whichever direction it is to the sun from the Earth is the same exact direction it is to the planet on its epicycle. So if the sun is straight up in the diagram, the planet has to be straight up in the diagram. And that's great, right? So now we have our starting position. Here's the process that's going to unfold. For every month that goes by, you're going to have to plot the new location for where that planet is going to be. So I can think of it as putting the large protractor in the middle, and what I'm figuring out is how far around has this thing swung in that month. In other words, the epicycle is being carried around the center, around the Earth, over and over and over again, at the same time that the planet is going around and 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 going around. But there's a rate to everything. So if I'm doing the 36-month-long planet, 36, there's 360 degrees to go all the way around the deferent once. If there's 36 months, 360 divided by 36, every 10 degrees is where my planet is actually going to move, because that is 36 months to make it one trip around. The sidereal period of the planet is 36. Now, I'm not going to draw them all in, but I'll get out here to the 90-degree mark. And then you would just continue every 10 degrees. If you're doing the 60-month problem, got to divide 60 into 360 and figure out where would you put that little mark. What's it times 2, times 3, times 4, times 5, times 6? Obviously, they'll be a little closer together because you got to get 60 months in one trip. But by the time you finish this circle and you come all the way around, 36 months later, this should be times 0 as well as 36. or 60, depending which problem you're doing. So once I have that, then I can come in here with my little protractor, and that's why I needed the center punched out. I can say, okay, there was time 0. I'm going to keep this lined up, right? I'm going to keep this up, down, left, right, lined up to my grid. If you had graph paper, it'd be even better, right? But I'm going to keep it lined up to this, and it's just going to move around like this. And what I want to do is move the planet around on this as it goes around. And so what I need to do is make it move at the correct rate. For this drawing challenge, the key is the rule for a superior planet is wherever the sun is in its direction from Earth is the same direction as the planet is on the epicycle. So if this is 1 month later, 2 months later, 3 months later, is 90 degrees away from where it started, that means it's 30 degrees per month. So the center of the epicycle is going to shift at the rate of this dot to that dot. This is 1 month. You can number these. This is 1 month. This is 2 months. This is 3 months, 4, etc., 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 all the way around to 36. But what I'm going to do is say, okay, here's my starting point. Bam. 1 month later, I come sliding along until I see my little mark is centered in the middle. I'm going to double check to make sure I'm still lined up with my grid. That looks nice. And now it's not here anymore. It's not at the top because 1 month later, the sun is now over there, 30 degrees away from where it was. And so I've got to come over 30 degrees away from where I was. And I'll put in the same symbol, a little X with a circle around it for my superior planet. You can make up any symbol you want. Have some fun with it. And that is 1 month into the cycle. Okay, 2 months later. Whew. All right, 2 months. The sun will have toggled to here. Right, it's 2 months. The sun is whipping around the Earth. It takes 12 months to do that. So now it's 60 degrees off of where it started. And I take my protractor, my epicycle out here, and it's the same thing. It moved forward 1 month. It moved forward 2 months. I'm double checking my alignment, make sure this is still lined up nicely with that, but it's not here. It hasn't moved just 1 month, 30 degrees, like the sun. Now it will have moved 60 degrees, like the sun. In other words, the Ptolemaic rule of a superior planet is always from the center of the epicycle in the same exact direction, parallel direction, to the path to the sun. That same exact direction is out here. And what you'll do is you'll get a whole bunch of these little symbols, and you'll either get 36 of them, or you'll get 60 of them. And when it's all done, what you'll do is come back in, and you'll be able to say, let's trace out the orbital path. And we could actually tell things like, is the planet actually getting closer or farther from the middle? Which means if it's getting closer, it should be getting brighter. If it's getting farther, it should be getting dimmer from our perspective. And can we get it to do a retrograde loop? If out here is the fixed sphere of the stars, and we're going to just act as if we don't let that move. We're going to ignore daily diurnal motion, and we're just going to act as if my fixed stars are out here somewhere. Then in comparison to them, can we have the planet spend most of its time going in one direction, and every once in a while go into a retrograde loop? That's the key to these assignments. So by the time we're finished, you should be able to see how Ptolemy's system accounts for annual motion of the sun, how Ptolemy's system accounts for the planet's direct motion and retrograde motions, and for the times when the planet appears stationary, right, going into and out of retrograde, how Ptolemy's system accounts for the apparent variations in the speed of a planet in its orbit about the Earth, Earth-centric system, how Ptolemy's system accounts for the apparent variations in the speed of the planet in its orbit about the Earth, so why it looks like it speeds up, slows down, how Ptolemy's system accounts for a planet's systematic variations of brightness, closer, brighter, farther, dimmer, and finally, how Ptolemy's system can account for a superior planet undergoing retrograde motion only as it approaches and passes opposition. We have to save the appearances. Since the time of Plato, that has been the mandate. And this drawing project will make it clear how the Ptolemaic system does that. Once again, I hope you have fun with it. Oftentimes, when you're done with these, the first time is a little sloppy, and people like it so much they want to draw it again nice and neat. And I've had people frame them. They're so gorgeous. So if you're an artist, go crazy. This is a time to really leverage those artistic skills. This is Ben Senson from Madison College and James Madison Memorial High School for the Ptolemaic Drawing Challenge number 1, Ptolemy's Model for a Superior Planet. All right, we'll see you for the next one.